Hi, Andrew here, and this evening
I'm free.
to discuss the challenges that the final experiment released this week. And Flatside, if you're watching, I've got some bonus predictions for you as well. Now, there were three challenges. The first one was about predicting the flight distances the participants were going to cover on their way to arriving in Santiago, Chile. The second was about predicting the sunrise and sunset times and azimuths in Punta Arenas. And the third one was about predicting the distance between meridians in Punta Arenas. Or you can think of that as predicting the length of the latitude circles in Punta Arenas. Now, I didn't actually make any submissions to these challenges because, frankly, for the Globers, it's all too easy. There's a plethora of tools you can use to find out the answers to these questions. And so it really wasn't worth putting in a submission. But Flatties, well, it'd be interesting to see your submissions to these because we all know there's not really a map, there's not a model. We're very intrigued at how you would come out with some answers to these things. Okay, and on to the first challenge, that of the flight distances. Participants in the final experiment are coming from 4 airports: London, Atlanta, Los Angeles, and Critical Think is coming from Sydney, all convening on Santiago. It's a major airline hub in Chile, in order to then catch flights down further south to Punta Arenas and then down to Antarctica. No great challenge on the globe to find some resources to tell you the distances between those. You can use the haversine formula, work it out yourself by hand. I use a website called greatcirclemap.com. Pretty easy. Put in the airport name or airport code of 2 airports, and it'll join them together with a line and tell you how far away they are. It also displays them on a Mercator map, which you might be familiar with if you see some of Flat Earth Banjo's emergency flights or emergency landings. He likes to look at these things projected on a Mercator map and say, that does not make any sense. Why aren't they travelling in straight lines? He needs to learn to put them on a globe representation like this and see that they make nice, perfect straight lines. Now, the actual distance the planes travel is not the Great Circle distance. That is the minimum. They will spend a little bit of extra distance in traffic patterns coming in and out of the 2 airports at each end of their route. But more significantly, they will deviate from these Great Circle routes to find favourable winds. That'll reduce the flight time, but more importantly for the airlines, it will reduce the fuel burn and save them money. So if you did make a submission to the final experiment for this particular challenge, you would take those numbers, you would add a little bit extra. How much extra? Don't know. The actual flights that the participants take on, you don't know what exact distance they're going to have. Bit of a randomness to who is end up going to win these 2 challenges. More importantly, very interested to see what Flat Earth submissions there are to this, because in order to do this, you need to have a map and a way of working out distances between places on a map. Now, as of right now, you could work out when I'm recording this, because as of right now, if we switch over to Flight Radar 24, let's click onto this plane, there is QF27. That is the exact plane that Critical Think is on at the moment. Going to land in Santiago in 1 hour and 42 minutes. I was watching, he did a couple of lives this morning as he was travelling from Brisbane to Sydney and at Sydney International before he got onto the plane. And interestingly, right next to that Qantas airplane is a plane from LATAM Airlines. Now, it left Melbourne, Australia, probably about the same time as the Sydney one, and they are coming into Santiago around about the same time. Now, interestingly, I happened to see at Melbourne Airport last year a LATAM plane, and I thought, my goodness, that's one of these flights that don't exist, and here's a plane in Melbourne. Noted down its tail number, noted that it was starting to taxi away from the international terminal, and throughout the course of the day, followed the plane on flight radar, and sure enough, about 12 hours or so later, it landed in Santiago. So yes, these flights do exist. Critical Think is proving it now, because if you look back at his videos, he was definitely in Sydney Airport about 12 hours or so ago, and he will no doubt try and live stream as soon as he gets into Santiago, just to prove that he actually got there in the amount of time that he's supposed to. Okay, so that's that challenge done. And on to the second challenge, that being the sunrise and sunset times and azimuths for Punta Arenas, for the times when the participants from the final experiment are there over the next few days. Now, if you saw my Margate Sunrise project from, I think it was about 4 weeks ago, I was using Petey 194's GeoGebra project here to make my predictions, and they got remarkably good close to the predictions made by websites such as timeanddate.com. Now, there's going to be a lot of numbers in this little section. It's going to be a little bit dry, but I'll run through this, and I'm going to make some predictions for other locations. Let's take note. But I'll take through a fairly detailed run through of this first one. Now, Petey's project here is just based entirely on a spherical Earth of a certain size. Now, it doesn't model it as being spheroidal, so that may make for some very, very minor discrepancies between his predictions and those made by time and date and things like that. But it's just made on a spheroidal Earth of a certain size and the sun of a certain size and a certain distance away, and how that geometry interacts. The only thing it does beyond that is when you put the sun at sunrise or sunset, it makes a minor adjustment for the angular size of the sun because of the way sunrise and sunset are defined in prediction charts. And also it makes about a half a degree correction for refraction, which lifts the sun up when it's near the horizon. And just those two little tiny corrections are enough to take the simple geometry, add in these optical effects, and come up with some really, really close answers to those produced by much more involved models. So I've got our location here sent to Punta Arenas, which is this big red circle down here. And at the moment it's at solar noon, but we're going to go to sunrise where the sun is over here, over the Indian Ocean near Madagascar. And I've got to hit this little adjust button. It's very important to make those little tiny adjustments. And it shows that if we look here from Punta Arenas, the white arrow is pointing towards true north, towards the North Pole. And the orangey arrow here is pointing in the direction of where you would see the sun. And as you can see, it's around about southeast. Petey's prediction is 132 degrees azimuth. Now we're going to switch over to sunset, where the sun is here over the Western Pacific, getting close to Australia. Same deal, let's just confirm what it's going to be. It's going roughly to the southwest. The prediction is 229 degrees. Oops, no, sorry, didn't hit the adjust button. 227, well, 228 degrees. Now, also important, it shows here the day length is predicted to be 16 hours and 51 minutes. So Petey's project here doesn't tell us what the local time will be when sunrise and sunset happens, but from this we can extrapolate and make our own prediction based on that, because half of that day appears before local solar noon and half of that day occurs after local solar noon. So if we just know what the civil time is when solar noon happens, we can go 8 hours and 26 minutes one way and 8 hours 26 minutes the other way, and find out what our predicted sunrise times are. Now I've used time and date to find that out for Punta Arenas at the time, and I'll take you through that in a second. Important thing to note though, that is I don't know what day the final experiment are going to be doing their observations on. It'll be over the course of 2 or 3 days before they travel to Antarctica. So there might be a little bit of discrepancy with the predictions that I make right now and what the predictions of the day that they actually do their observations. It's not going to make a huge difference because we are close to the December solstice. The sun here is moved almost as far down as the Tropic of Capricorn, and its rate of movement towards that slows down, and on the solstice around about the 21st, 22nd of December, that southward movement stops and goes back north again. So the difference between a couple of days either side of the solstice is not going to make a huge amount of difference, especially when we're only making our predictions to the nearest 1 degree. So it's not really going to make a huge amount of difference. But I'm making the predictions as of, I think, right now of what they're going to be. So I've had our two sunrise and sunset angles of 132 degrees and 228 degrees. Now, for our sunrise and sunset times, so according to time and date, local solar noon down here, and let's do this. Local solar noon in Punta Arenas occurs at the civil time of 1:36 p.m. So from 1:36 p.m., we're going to take, let's just get that number back up there again. We're going to take half of that 16 hours and 51 minutes, so around about 8 hours and 25 minutes, give or take a few seconds. And so from the local solar noon occurring at 1:36 p.m., if we go 8 hours and 25 minutes before that, we get 5:11 a.m. And if we go 8 hours and 25 minutes after that, we get 10:01 p.m. Now, just going to show on screen Petey's predictions that I've got out of his program versus timeanddate.com for the same day. And we see that they're pretty much exactly the same. Petey's prediction, 5:11 a.m. at 132 degrees, and sunset at 10:01 p.m. at 228 degrees. And that's it's 1 minute out there. I may have done a little bit of rounding errors, but there we go, close enough. Now, important thing to also note is that when using a compass like I did in Margate, and I mucked up my prediction and then corrected myself on that, if using a magnetic compass to get these directions, you'll have to account for magnetic declination. Now, if we go down here to a world magnetic declination map, and we go down here, Punta Arenas is down here right in the bottom of South America. It sits at around about 14 degrees eastward magnetic declination. So what that means, and this is what I got around the wrong way in Margate, is when you take your prediction of true direction. For example, the sunrise was predicted to be 132 degrees true direction. Then you need to subtract off 14 degrees off that. So that would be 118 degrees magnetic is the prediction for the sunrise direction. Same thing for the sunset, 228 degrees true, 214 degrees magnetic. Okay, so that's Punta Arenas done. Now, we can also do this for Union Glacier. It's a little bit simpler for Union Glacier. So let us go back to Petey's project and move ourselves to Union Glacier. And there we are, Union Glacier, all the way down there. Okay, now there is no buttons here for sunrise and sunset because Petey's project correctly identifies that there will be no sunrise and sunset with the sun this far south near the Tropic of Capricorn. So none of that, and indeed, whoops, I'm just going to do something there to get it to recalculate that. No, it's not going to do that for me. Anyway, it was showing there. Wait a second, I will get that to happen. Come on. Oh, I've lost the ability to do that. Anyway, it had up there a day length of 24 hours, which is to be expected. What we can do, though, for Union Glacier is predict the path of the sun. More importantly, the altitude angle of the sun, elevation angle of the sun at solar noon and solar midnight. Now, at the moment, it's set to solar noon, and we have an altitude angle of 33 degrees. And we're now going to move to solar midnight, which is going to take a little bit of fiddling around here to move the sun. It's going in the wrong direction, but it doesn't matter. We just need to get it around to the other side here. There we go. That's good enough there. Heading 178, we needed 180, but that's close enough. And it has an altitude of 12.8 degrees. Now, if you've been paying attention to some of the things that have been said about the expectation of the sun at Union Glacier, generally speaking, we've talked about it being at midnight, it being about 13 degrees elevation. There you go, Petey says about that. And being about 33 degrees elevation at solar noon. And Petey's one correctly does that as well. Oh, we've got the 24-hour day showing up here. So completely as expected. And matching the predictions that we've all talked about. So that's Union Glacier done. Now for some bonuses. Now, Flatslide, I'm sure you have tuned out by this time, but I'm going to move us up to location 36 in Petey's list, and that is a place called Tabazimbi, South Africa. And I'm going to quickly do the numbers on that, hit the adjust, and we're going to have it for Tabazimbi. I'm just going to refer to my notes here while I go through this very, very quickly. A sunrise of 116 degrees, true, and a sunset of 244 degrees true. Day length of 13 hours and 37 minutes. And now, based on solar noon being 12:03 civil time, so it's almost perfectly aligned with civil time. Sunrise expected to be 5:14 a.m. Sunset expected to be 6:52 p.m. Now, Flatsoid, if you're going to go and do this one while you're at home over the next few days, magnetic declination at Tabazimbi is 20 degrees west. Now, here's the tricky bit. you need to add 20 degrees to those predicted true azimuths to get your magnetic azimuth. Okay, and one last thing. Flatzoid is going on holidays in the next few days. Now, I'm going to assume he may be going to Margate again. I really hope he is, because this time he can actually film the sunrise, not like he did last time. Now, oops, play around with him. We're going to go to Margate, South Africa. And again, we're just going to hit the buttons again. Sunrise at 117 degrees, which, if you remember last year, on around about the solstice, which is we're getting pretty close to it, Where's Wally predicted 118 degrees for the sunrise. So what do you know? Come around the same time next year, it's the same again. And we're going to predict sunset of 242 degrees. Now, I know, Flatzoid, you don't get quite as good a view of the sunset at Margate as you get of the sunrise, but there it is all there. Okay, and that is it for challenge 2. And finally, we are on to challenge number 3, which thankfully, compared to challenge number 2, will be over and done with a lot quicker. Not pages and pages of numbers to wade through. So the challenge is to predict the distance between longitude lines at Punta Arenas. For example, how far is it between 1 degree of longitude at 53 south? It might be easier to think of it as I do, as what is the length of the latitude circle at 53 south, and then break it up into, say, 360 degrees or something smaller than that, and think about it that way. So how do we do it? It's actually pretty simple for the globe. The equator is 40,075 kilometres long, and the latitude circles decrease towards the South Pole, where they are 0 kilometres long, because everything converges to a point down there. And the relationship, because it is on a sphere, or a spheroid at least, the relationship is the cosine of the latitude as a scaling factor of the equator. So when you start at 0, the cosine of 0 is 1, so you multiply your 40,075 by 1 to give the length of the equator. That's pretty obvious. And down at 90 degrees south, the cosine of 90 is 0, so you multiply the 40,075 by 0 to get the length of the 90-degree latitude circle. Fairly obvious. And a cosine relationship in between. So Punta Arenas is at 53 degrees south, so the cosine of 53 is 0.60. So you multiply that by the 40,075 of the equator, and you get the 53 south, or 53 north indeed, latitude circle is 24,017 kilometres long. To put it in something a bit more meaningful, divided by 360, so 1 degree of longitude at 53 south is about 67 kilometres. So when they're down there doing these things, MC Toon has talked about taking a laser distance meter, rangefinder, and a GPS, finding 2 locations, measuring the distance between them, and comparing their longitudes along the same latitude line. Very important to do that. And scaling it out, and then working out what 1 degree of longitude distance would be is probably the metric they're going to be looking at. So 67 kilometres per 1 degree of longitude at Punta Arenas is the globe prediction, or my prediction at least, using this basic trigonometry. Now, at Union Glacier, it's not part of the challenge, but at Union Glacier, they are close to the pole, so therefore longitude lines are converging much closer together. So they are very close to 80 degrees south. So the cosine of 80 degrees is 0.17. Multiply the length of the equator by 0.17, so I'm looking at my notes here, and you get about 6,900 and something kilometres for the 80 south latitude circle, divided by 360, and 1 degree of latitude is about 19.3 kilometres. So compare 67 kilometres at Punta Arenas and 19.3 kilometres at Union Glacier. So pretty easy on the globe. Interested to see what any flat Earth predictions are going to be for this. In order to do this, you need to know what the shape of the Earth is. You need to have a map, for example, to work these things off. Flat Earthers tend to agree that longitude lines converge at the North Pole and splay out towards the equator. They certainly do not agree that they reconverge back at the South Pole. They should get further and further and further apart. So interested to see what they're going to produce as any predictions, because it will tell us what sort of map they believe is a representation of the flat Earth. And so there you go, my workings out for all three of the final experiment challenges. Again, I didn't bother submitting my answers. Frankly, there'll be a lot of people on the globe side submitting pretty much the same answers to everything. Although good luck if you have, and more importantly, um, very very interested to see what the flat Earth submissions, if any, are going to be. And now, interestingly, I have spent so long making these recordings that Critical Think is just about to land in Santiago. So I will say goodbye now and switch over to Flight Radar 24, watching QF27 landing in Santiago. So good luck to everyone involved in the final experiment. Hope you have safe travels to and from Antarctica and back home again. Hope you all, not too many arguments going on. And most importantly, hope for some lovely clear weather to be able to see the sun going around and around and around in circles and liberating those flirt tears. So Andrew out, and let's go join Critical Think landing in Chile. See you later.